Hello students, myself Don ALS. Today I am going to prepare a video on one important thermodynamics topics. I have also prepared the number of videos on the same thermodynamics topics, and I have shared these videos on my YouTube channel. Please friends, go and watch the previous video I have shared on my YouTube channel and like the particular video and subscribe to my channel. So my today's presentation topic is units for mass, length, time and force. And what is meant by units? What are the different types of systems of the units? Today I am going to discuss in this my video. So friend, just I am going to start my video, my topic. First of all, we must have to know what is the definition of the unit. What is meant by unit? So, unit is nothing but a standard which is used to measure any physical quantity. Let us suppose we have to measure any physical quantity. To compare this physical quantity with a particular standard quantity, we can use the unit. So there are different methods to give the units. So first method is SI unit, which is known as International Standard System of Unit, SI unit. Second one is the MKS. What is meant by MKS? MKS. M means meter, K means kilogram, and S means second. This is known as MKS system. CGS system, centimeter, and then gram, and second. Third one is the FPS system. F means foot, P means pound, and S means second. So these are the different methods were used to denote the units. MK system, CGS system, and FPS system. F means foot, P means pound, and S means second. So LMT. What is meant by L? Length, mass, and time. Length, mass, time. These are the fundamental units. Similarly, also there are four fundamental units, which are: one is temperature, which is measured in Kelvin. Then luminous intensity. Luminous intensity is measured in candela, which is denoted by CD. Similarly, there is another fundamental unit. What is the another fundamental? Ampere. Current is measured in ampere. And length, mass, time. So these are the seven fundamental units: length, mass, time, temperature, luminous intensity, which is measured in candela, current, which is measured in ampere, and last one is the amount of substance, which is measured in the mole. Amount of substance, which is measured in mole. So these are the fundamental units. These are the fundamental units, and another units are derived from these fundamental units. So first of all, we must have to know what is the relation between the force, mass, length, and time. And this relation is given by the Newton's second law of motion. So what is this Newton's second law of motion? See friend, what is the Newton's second law of motion? F is directly proportional to mass into acceleration. Here F is nothing but a force which is measured in Newton. F is force which is measured in Newton. Then mass is measured in kg. Mass is measured in kg. And acceleration, which is measured in meter per second square. Meter per second square. So now 1 Newton is derived. What will be the value of 1 Newton, friend? 1 Newton is equal to 1 kg, 1 kg meter per 1 kg meter per second square. Meter per second square. So this is the relation between 1 Newton and kg meter per second square. So this is given by the Newton's second law of motion. F is directly proportional to the mass and acceleration. So what is the statement of Newton's second law of motion? The statement of the Newton's second law of motion is that the force acting on the body is proportional to the product of mass and acceleration in the direction of force. So in the direction of force means what, friend? Force is a vector quantity. Force is a vector quantity. What is the meaning of vector quantity? The quantity having mass as well as direction. No, sorry. The quantity having magnitude as well as direction, which is known as the vector quantity. So what is the definition of force? Force is nothing but pull or push action acting on a particular body. The pull or push action, which is known as a force. So we are going to discuss the concept of time. See, friend, time is a well-established term. Time is a well-established term. The SI unit or basic unit of the time is second, which is denoted by small s, which is denoted by letter small s, and which in the past was defined in terms of solar day. The time in the past was defined in terms of solar day. The time in the past was defined in terms of solar day. What do you mean by solar day? The time interval for one complete revolution of the earth relative to the sun, which is known as a one solar day. One solar day is nothing but the time interval for one complete revolution of the earth relative to the sun, which is known as one solar day. Since this period varies with the season of the year, since this period means one complete revolution of earth related to the sun, this period varies with the season of the year, and due to this an average value of over a 1 year period is called as mean solar day. The average value of 1 year period is called as mean solar day, and the mean solar second is given by the particular value 1 by 86,400 of the mean solar day. What is the value? 1 by 86,400 of the mean solar day. See, friend, the earth rotation is sometimes measured relative to the fixed star. Earth rotation is sometimes measured relative to a fixed star, and in which case the period is called as sidereal day. Sidereal day. When sometime the earth rotation is measured relative to a fixed star. In such a case, this particular period is called as sidereal day or sidereal day. So in 1967, see friend, in 1967, the General Conference of Weight and Measures, which is also known as in short form the abbreviation of the General Conference of Weights and Measure, which is known as C means conference, G means general for weight and measure, adopted a definition of second as a time required for a beam of cesium 133 atom to resonate 192 631 770 cycles in a cesium resonator. So what is the definition? Define for the second in a conference, CGPM conference, in 1967, the definition adopted for second is as the time required for a beam of cesium-133 atoms to resonate 9192631770 cycles in a cesium resonator. So this was the definition adopted by the CGPM for a second. So friend, it is clear. Up to this, I think this is clear to all of you. Now we will move towards the next topic or next bit of the today's lecture. So what is the next point? See, what is the next point? Unit prefix. What are the different types of, what are the different unit prefix were used for particular unit? So see friend, here the factor 10 to the power minus 3. See friend, this factor 10 to the power minus 3, which is denoted by a prefix milli. 10 to the power minus 3 means milli, and which is denoted by a symbol m. The value 10 to the power minus 6, which is denoted by a prefix micro, which is known as micro. 10 to the power minus 6 means micro and denoted by a symbol mu. The value 10 to the power minus 9, which is denoted by a prefix nano and denoted by a symbol n. 10 to the power minus 12, which is known as pico and which is denoted by a symbol p. So these are the prefix. Now similarly for positive, when 10 to the power 3 is known as a kilo denoted by a k. 10 to the power 6 means mega denoted by capital M. 10 to the power 9 means giga, which is denoted by 10 to the power 9 and denoted by a symbol capital G. And 10 to the power 12 means tera, which is denoted by the T. So such types of symbol or prefix used in a numerical, when such type of symbols or prefix comes in the numerical, at that time you must have to know what is meant by milli, what is meant by micro, what is meant by nano, and what are the value of that prefix. So this is very important for solving the numericals. So such type of basic knowledge of the prefix everyone must have to know while solving the engineering problems. So now this is clear to all of you. Okay, now we will move towards the next point of the today's lecture. So this is all about the prefix. Please keep in mind this 8 prefix for the calculation purpose. Now we will move toward the next point. See, what is the next point? The concept of length. What is the previously on first PPT we have studied that what is the concept of second. Now in this topic we are going to discuss what is the concept of length. So what is the standard of the length? So length is also well established. Length is the concept which is also well established. What is the SI unit of the length? What is the basic unit of length? The basic unit of length is meter, friend. What is the length? The basic unit of length is meter. For many years, the accepted standard was international prototype meter. For many years, the accepted standard was the international prototype meter. Then the distance between two marks on a platinum iridium bar under certain prescribed conditions, which is known as a meter. So, what is the standard for a meter? For many years, the accepted standard was the international prototype for the meter, and the distance between two marks on a platinum iridium bar under certain prescribed conditions is known as a meter. So this bar is maintained at International Bureau of Weight and Measures, Serres, France, in Serres or France. In 1960, CGPM adopted a definition for the meter as a length equal to 1650,763.73 wavelengths in vacuum of the orange red line of Krypton 86. Keep in mind this, friend. Krypton 86. What was the definition adopted by the CGPM in 1960 for meter? Was the one length is equal to 1650,763.73 wavelengths in vacuum of orange red line of Krypton 86. Then in 1983, CGPM adopted a more precise definition of the meter in terms of speed of light, which is now a fixed constant. A meter is the length of path. Meter is the length of path traveled by light in a vacuum during a time interval of 1 by 299,792,458 of second. So this is the precise definition adopted by the CGPM in 1983. Okay, friends, this is all about the length. Now we will move towards the next topic. I think this is clear to all of you. Okay, just a minute. I have to erase this part and I will move towards the next part of the just a minute, friend. So the fundamental unit of mass is the kilogram, as adopted by the first CGPM in 1889 and restated in 1901. It is the mass of a certain platinum iridium cylinder maintained under prescribed conditions at the International Bureau of Weights and Measures. A related unit that is used frequently in thermodynamics is mole. Which unit is frequently used in thermodynamics? The mole. Mole is a relative unit used frequently in thermodynamics, defined as the amount of substance containing as many elementary entities as there are atoms in 0.012 kg of carbon. These elementary entities must be specified. They may be atoms, molecules, electrons, then ions, or other particles or specific groups. For example, 1 mole of diatomic oxygen having a molecular mass of 32 compared to the 12 for carbon has a mass of 0.032 kg. The mole is often termed as a gram mole, and since it is the amount of substance in grams numerically equal to molecular mass. When using metric SI system, we will find it preferably to use the kilomole and the amount of substance in kilograms numerically equal to the molecular mass rather than the mole. So this is all about the kilograms or mass. Now we will move towards the next topic. So I think this is a last topic. I think this is last topic of the today's lecture. I think it is clear to all of you. So these are the references I have taken for the preparation of this topic or presentation. So friend, please watch the videos and like and subscribe to my channel. Thank you friends. Thank you.